More than 15 billion miles from Earth, a tiny spacecraft is still communicating with us. Every few days, an incredibly weak radio signal crosses the enormous distance between the spacecraft and Earth. That spacecraft is Voyager. It left Earth in 1977, at a time when the technology inside it was considered remarkably advanced. Today, its computers are primitive compared with even ordinary modern devices. Its power supply is steadily declining. Yet somehow, Voyager continues to send scientific information back home. And that's what makes its story extraordinary. Voyager isn't orbiting another planet. It isn't sitting on the surface of an asteroid. It isn't traveling toward another star. Instead, it is moving through an environment that no human has ever physically visited. A region beyond the enormous bubble created by our Sun. Out there, the environment is incredibly thin, but it isn't completely empty. There is plasma. There are magnetic fields. There are energetic particles. And there are waves moving through the charged material between the stars. Voyager is measuring these invisible phenomena directly. Every change in particle density, every variation in the magnetic field, and every plasma wave gives scientists another clue about what exists beyond our solar system. But there's something even more surprising. Voyager was never originally built specifically for this mission. Its main goal was to explore the outer planets. Jupiter, Saturn, and then continue outward. Nobody could have known that decades later, the spacecraft would become humanity's first scientific messenger operating in interstellar space. So what exactly is Voyager discovering out there? What is the environment between the stars actually like? And how can a spacecraft designed in the 1970s still communicate with Earth from such an enormous distance? To understand that, we need to go back to the beginning. When Voyager 1 launched in 1977, its mission was built around a rare opportunity. The planets of the outer solar system were positioned in a way that allowed a spacecraft to use their gravity to travel from one world to another. Voyager could visit Jupiter, then Saturn, and collect close-up information about worlds that humanity had previously observed only from Earth. The spacecraft successfully completed those encounters. But instead of stopping there, Voyager continued outward. It passed beyond the familiar planets and kept traveling into deeper space. Year after year, the distance increased. Then came one of the most important moments in the mission. Voyager approached the outer boundary of the Sun's influence. The Sun constantly releases a stream of charged particles known as the solar wind. Those particles travel outward in every direction, creating a huge region called the heliosphere. Inside this bubble, the solar wind dominates the surrounding environment. Outside it, the influence of the interstellar medium becomes much stronger. The boundary separating these two regions is known as the heliopause. In 2012, Voyager 1 crossed that boundary. For the first time, a human-made spacecraft entered interstellar space. Voyager 2 eventually followed. Suddenly, the mission had transformed. This was no longer simply a planetary exploration project. Voyager was now directly studying the environment between stars. And that's where some of its most valuable scientific observations began. We often imagine interstellar space as completely empty. But that's not quite correct. Even between stars, there are charged particles, extremely thin plasma, magnetic fields, and high-energy cosmic particles. Voyager's instruments can measure these things directly. That distinction is important. Telescopes can observe distant objects from Earth. They can collect light from stars and galaxies. They can study radiation traveling across the universe. But Voyager is doing something different. It is physically traveling through the environment it is measuring. It's like the difference between looking at an ocean from a satellite and actually placing a scientific instrument inside the water. Voyager is sampling the cosmic environment from within it. One of the spacecraft's important instruments is its plasma wave detector. Despite the name, these aren't ordinary sound waves. Sound requires a material medium such as air, water, or another substance capable of carrying mechanical vibration. Interstellar space is far too thin for ordinary sound to travel in that way. Instead, Voyager detects electrical oscillations occurring within the surrounding plasma. Those signals can reveal information about the density of the material surrounding the spacecraft. In other words, Voyager can use these waves to study the space around itself. Its other instruments measure magnetic fields and energetic particles. Together, these measurements allow scientists to build a picture of the interstellar environment. And that picture has revealed something important. Interstellar space isn't perfectly uniform. Conditions change. Plasma densities vary. Particles move. Magnetic disturbances travel. And waves can propagate through the extremely thin plasma. Voyager can detect some of these changes as it continues moving farther away from the Sun. Think of the spacecraft as a tiny scientific probe drifting through an invisible cosmic ocean. The ocean isn't water. It's plasma. The waves aren't ordinary waves. They're electrical and magnetic disturbances. And the entire environment stretches between stars. Occasionally, enormous disturbances originating from the Sun travel outward through the solar system. When these disturbances eventually reach Voyager's region, they interact with the surrounding plasma. The spacecraft can detect the resulting changes. Scientists can then study how those disturbances travel through space. But the most interesting information doesn't always come from dramatic events. Voyager has also detected weaker and more persistent plasma wave activity. It's more like a quiet background signal than a giant cosmic explosion. That faint activity can help researchers estimate the density of the interstellar plasma around the spacecraft. And because Voyager keeps collecting measurements over long periods, scientists can compare those observations and investigate how the environment changes. Before Voyager entered interstellar space, researchers had mathematical models and observations from within the solar system. But they didn't have a spacecraft physically traveling through the space between stars. Now they do. Voyager is slowly creating a direct scientific record of this previously unexplored environment. And these measurements aren't important only because they're far away. They also help us understand how our solar system interacts with the rest of the galaxy. The heliosphere acts as a huge boundary around the solar system. The solar wind and the Sun's magnetic field influence how energetic particles from interstellar space enter our region. So studying what happens beyond the heliosphere helps scientists understand the cosmic environment surrounding our solar system. Voyager is essentially sitting near the transition between the Sun's domain and the larger galactic environment. But that boundary isn't a simple wall. The heliosphere changes. Solar activity rises and falls. The pressure from interstellar space varies. Magnetic fields interact. Particles move through the boundary. And Voyager is providing measurements from within this complicated region. Unfortunately, the spacecraft itself is aging. Voyager's power comes from radioisotope thermoelectric generators. These power sources have operated for decades, but their available output gradually decreases over time. Engineers have therefore had to make difficult decisions. Scientific instruments and other systems are being turned off or managed differently so that the remaining power can be preserved for as long as possible. Eventually, there won't be enough electrical power to operate the remaining systems and maintain communication with Earth. Voyager won't necessarily stop moving. It won't suddenly crash into something. There won't be a physical wall bringing the mission to an end. Instead, the spacecraft will eventually become too weak to communicate. The machine will continue traveling through interstellar space, even after Earth can no longer receive its transmissions. That's why every new measurement matters. Each piece of data comes from an environment that no human being has ever physically entered. And every transmission could represent another step toward the final chapter of the mission. Yet Voyager continues. It keeps measuring. It keeps traveling. And, for now, it keeps talking. A spacecraft designed with technology from the 1970s has become humanity's first scientific outpost beyond the protective bubble of the sun. But perhaps its greatest achievement isn't simply the distance it has traveled. It's what the journey has revealed. The solar system doesn't simply end where the planets disappear.